the part B of the experiment 9. So in part B of experiment 9, what you're doing is you're given a bag that has a mixture of sodium phosphate and sodium chloride, although I wrote them backwards, sodium chloride and sodium phosphate. And the idea is that what you're going to do is you're going to find out the percent sodium phosphate. And so percent sodium phosphate is going to be the mass of the sodium phosphate over the mass of the mixture times 100, just like you did percent salt, percent sand in the mixture lab. And so in this case, we don't know the mass of the sodium phosphate, but we do know the mass of the mixture is 3.5116 grams. All right, so all we have to do is figure out the mass of the sodium phosphate. So how are we going to do that? This is called a stoichiometric determination of a mixture. So what we're going to do is we're going to dissolve this in water. Sodium chloride and sodium phosphate both dissolve in water. And then we're going to add copper chloride. And the copper chloride will react with all of the sodium phosphate in this manner to form copper phosphate. Then we filter it out. We determine experimentally the amount of copper phosphate we form. From the mass of the copper phosphate we form, we can back calculate how much sodium phosphate must have been there. And this works because sodium chloride does not react with copper chloride, and you can verify that for yourself. So this is the balanced equation. The sodium chloride doesn't do anything. So again, we're going to give you data. We will probably give you the mass of the mixture, and we'll give you the mass of the copper phosphate. All right. So, but first thing you would have to do, and this is on page 140, right under part B, it says balanced chemical equation. There's the equation. The first thing to actually do is you'd have to calculate, for this to work, you have to make sure that all of the sodium phosphate in the bag is going to react. That means you have to make sure that you have plenty of copper chloride. Now the catch-22 is we don't know how much sodium phosphate's in the bag, but we can assume that there's no more than 3.5116. So what we could do is we could do this calculation. We would take the 3.5116 grams, that's a 6. We're going to assume it's sodium phosphate. It's not, but we're going to assume it is for this calculation. And then you convert to moles. I'm trying to squeeze stuff in here. I probably shouldn't do that. Using the molar masses that I gave you before. We know that there's 3 moles of copper chloride for 2 moles of sodium phosphate from the balanced equation. Just kind of wall this off here. And there's 170 grams of copper chloride per mole of copper chloride, which means to make this work, we're going to need 2.3624 grams of copper chloride. So if you were actually doing this experiment, what you would do is you'd go to the balance and you'd make sure you weighed out at least that much copper chloride if that was the mass of your sodium phosphate, of your mixture. Now, once you do that, you do the whole reaction like we showed you in the video. Let's say we did this, and when we were all done, we got 0.8831. I'm just making these numbers up right now. So we did the reaction and we got this much copper phosphate. We want to find out how many grams of sodium phosphate were in the mixture. And so we would do this stoichiometrically, because then we would know the percent of sodium phosphate. So we take the grams of copper phosphate, and these are all, see, this calculation is on page 140, and it's the second line up from the bottom. In your lab manual, on the online thing, it'll be in a different place probably. We use the molar mass of copper phosphate. Remember the molar masses from the previous video. Right? And then we know from the balance equation that there's 2 moles of sodium phosphate per mole of copper phosphate. And we know that there's 380 It's one of the many dogs living here right now. And that means that if we got this much copper 2 phosphate and did that reaction, there must have been 1.545 grams of sodium phosphate. And so this number here is the mass of sodium phosphate, 1.545. And so that means that in this example, the mixture was 43.99%. Right? So that's walking you through the calculations. The lab manual does the same thing, but now you just have a couple examples, and so that should help you with part B of this lab. You have extra time on this lab because it's a bit complicated, but knowing how to do stoichiometry like this is a big deal as you go forward into Chem 200. Make sure you use the lab manual to help you watch this video and take liberal use of the pause button. Have a good one. Hope you're all well.